Today we're covering train and bus fare monitoring and how to scrape ground transportation prices in 2026. While flight price tracking gets most of the attention, ground transportation fares represent a massive blind spot for travel data collection. Trains, buses, and coaches operate with dynamic pricing models that rival airlines in complexity, yet far fewer tools exist to monitor them. This guide covers how to scrape and monitor fares from major ground transportation providers like Amtrak, FlexBus, National Express, and Eurostar, including the proxy infrastructure needed to do it reliably in 2026. But ground transportation pricing has evolved dramatically in the past decade. Gone are the days of flat-rate bus tickets and simple zone-based train fares. Modern rail and bus operators use yield management systems similar to airlines. The same journey can cost 2 to 5x more depending on when you book and when you travel. Prices change dynamically based on demand forecasts, seat availability, and competitive pressure. Early booking discounts can save 50–70% on popular routes, and advanced purchase windows vary by operator. Some releasing tickets 12 weeks out, others just 4 weeks. Multi-leg journeys often cost less when booked as separate segments rather than a single through ticket, or vice versa depending on the operator. For travelers, businesses, and travel aggregators, monitoring these fares over time reveals booking patterns that save real money. Some aggregators consolidate fares from multiple operators, making them efficient targets for monitoring. Trainline covers most European rail operators in one search, so scraping it can replace scraping individual operators for many routes. Omio, formerly Go Euro, compares trains, buses, and flights across Europe. Wanderu is a US-focused bus and train aggregator covering Amtrak, Greyhound, FlexBus, and others. Rome to Rio is a global multimodal transport search, useful for route discovery but less precise on pricing. Ground transport websites typically follow a search results selection flow that differs from airlines in important ways. The user enters origin, destination, and date, and unlike flights, ground transport usually searches one direction at a time. The results page then shows multiple departures with prices for each, and many operators display all fare classes for each departure right there on the results page. The user selects a specific departure and fare class, with additional options like seat selection or luggage appearing next, followed by a final price confirmation before payment. For fare monitoring, you typically only need the first 2 steps. The results page contains all the fare data you want, which simplifies scraping compared to airline sites that often require progressing further into the booking flow to see accurate prices. FlixBus is one of the more scraper-friendly ground transport operators because much of their data is served through a structured API. Search results are loaded via API calls that return JSON data. You intercept the network requests during a normal search to identify the API endpoint and parameters. The API typically accepts origin city ID, destination city ID, date, and passenger count, and the response includes departure times, prices, transfer information, and available seats. City IDs can be discovered by scraping the autocomplete endpoint or maintaining a static mapping. API-based scraping is faster and more reliable than DOM scraping, but FlixBus does implement rate limiting and may require residential proxies for sustained collection. Amtrak's fare monitoring requires handling several unique aspects. There are multiple fare types: saver, value, flexible, business, and first class where available, each with different refund and change policies. Long-distance routes like the California Zephyr and Empire Builder span multiple days, so results display differently than short-haul corridors. Sleeper accommodations like roomettes and bedrooms have separate pricing from coach and change independently. Some results also combine Amtrak segments with throughway bus connections, which carry fixed pricing. Amtrak's website uses JavaScript rendering for search results, requiring a headless browser or API interception. Their anti-bot measures are moderate compared to major airlines, but include rate limiting and captcha triggers for high-volume access. Eurostar presents the most challenging ground transport scraping target. It uses a heavy JavaScript single-page app architecture with aggressive anti-bot measures, including browser fingerprinting, dynamic loading of fare data with encrypted request parameters, and geo-restrictions that show different pricing to users in different countries. For Eurostar, mobile or ISP proxies are recommended. Rotating residential proxies have moderate success rates of 50–65%, while data center proxies fail almost entirely. Ground transport pages are generally lighter than airline booking pages because they have fewer results per search and less complex UI. API-based scraping like FlexBus or some Amtrak endpoints runs 10 to 50 KB per request. Headless browser scraping for Eurostar or SNCF requires 500 KB to 2 megabytes per search. Standard HTTP scraping for National Express or Greyhound falls in the 100 to 500 KB range. For a monitoring setup covering 200 routes with daily scrapes across 7 departure dates each, you would make approximately 1,400 searches per day. At 500 KB average per search, that is roughly 700 megabytes per day, or about 21 gigabytes per month of proxy bandwidth. Ground transport routes are defined differently than air routes. A city may have multiple stations. London has Euston, King's Cross, St. Pancras, Paddington, and others, each served by different operators. Your system needs station-level granularity. You also need to track direct and one transfer options separately, as they represent meaningfully different products. A London to Edinburgh journey might involve LNER, Avanti, or Lumo trains plus cross-country connections, each with independent pricing. On many corridors like London-Bristol, New York-Philadelphia, or Paris-Lyon, buses and trains compete directly, so monitoring both gives a complete market picture. A powerful application of ground transport fare monitoring is cross-modal comparison, showing users how train, bus, and flight options compare for the same journey. This requires normalizing across fundamentally different products. Total journey time should include transit to or from the station or airport, where trains typically have a city center advantage. Flights in Eurostar require advanced check-in, while most trains and buses do not. Most trains and buses include generous luggage allowances, while budget airlines charge separately. Carbon footprint is increasingly relevant to travelers, and trains typically produce 70 to 90% less CO2 than flights for the same route. On-time performance data, where available, adds a valuable comparison dimension. Unlike flights which have fixed route numbers, ground transport schedules can change seasonally. A train that runs at 08 Fare 1 in summer might not exist in winter. Build your monitoring to rediscover available departures periodically rather than hard-coding specific train numbers. Handle no service results gracefully, since the route may exist but no trains run on a given date, and track timetable changes as data points, since schedule modifications often signal demand shifts. In the UK rail market, split ticketing means buying separate tickets for segments of a single journey and can save 30 to 60% on many routes. Monitoring split ticket opportunities requires scraping individual segment prices for common split points, calculating whether the sum of segments is cheaper than the through fare, and verifying that the train actually stops at the split station without the passenger needing to change trains. This is a niche but high-value application of fare scraping that applies specifically to UK rail travel. Set up price alert functionality by establishing a baseline price for each route and departure time using a rolling 7-day median, then triggering alerts when the current price drops below a threshold, like 20% below baseline. Track saver fare release events when operators release new batches of discounted tickets, and monitor availability closely as the departure date approaches, since fares jump sharply when cheap buckets sell out. Online is ground transport fare data less protected than airline data? Generally yes, but with exceptions. Most bus operators and smaller rail companies have weaker anti-bot defenses than airlines or OTAs. However, premium operators like Eurostar, Trainline, and SNCF invest significantly in anti-scraping technology. The overall landscape is less hostile than airline scraping, which means you can often use lighter proxy infrastructure like rotating residential rather than mobile, but you still need proxies for any sustained monitoring operation. How far in advance should you start monitoring ground transport fares? This varies significantly by operator. Amtrak releases schedules and fares 11 months in advance, but saver fares often appear 6-8 weeks before departure. Eurostar opens bookings around 6 months out, with the cheapest fares available at release. Flixbus typically shows fares 3 to 6 months ahead. National Express releases fares up to 3 months in advance. For optimal coverage, start monitoring when tickets become available, and scrape daily as the departure date approaches. The most price action happens in the 2 to 6 week window before departure. Can you build a combined flight and ground transport comparison tool? Yes, and there is significant market demand for this. Many travelers overlook ground transport alternatives on routes where trains or buses are competitive, like Paris-London, New York-Washington, or Tokyo-Osaka. The main challenge is normalizing the comparison fairly. A 2-hour train at $80 is not directly comparable to a 1-hour flight at $60. When you add airport time, security, and baggage fees, present the data with total journey time, total cost including getting to and from the station or airport, and comfort factors, and let the user decide. What is the best database structure for time series fare data? Postgres with the timescale DB extension is the most practical choice for most teams. Create a hypertable partition by scrape date with indexes on route, operator, departure date, and fare class. Store raw scrape data and pre-compute derived metrics like daily average, minimum, maximum, and median in materialized views that update on a schedule. Plan for approximately 500 bytes per fare record. A 200-route daily scrape operation generates roughly 250 megabytes per year of raw data. How do you handle operators that require cookies or session tokens to show prices? Many ground transport sites require an active session set via cookies during the initial page load before the search API will return results. Your scraper needs to visit the homepage or search page first, collect the session cookies, and include them in subsequent API requests. With rotating proxies, this means each new IP requires a fresh session initialization, adding 1 extra request per search. Use sticky sessions, maintaining the same IP for the homepage visit and the search request, to keep the session valid. Some operators also set CSRF tokens that must be extracted from the page HTML and included in search requests. That's everything for today on train and bus fare monitoring and scraping ground transportation prices. Until next time, take care.